we have seen about decision tree algorithm, and we have created a case study on this decision tree algorithm on iris dataset, right, in which we have finished with the eda part of iris, and now we are going to build some machine learning model on this iris dataset. Okay. So, guys, as I already informed you in the last lecture as well, that today we are going to build the machine learning models, the different types of models on this particular data. Okay, so let us execute that. Um, so let's divide the data first. So this is my data frame. If you remember, it looks something like this. So we have over here four columns, right? Four features in X and one column in your target variable, right? Four features in X and one feature in your target variable. So let's divide this data into X and Y. So we need all the rows, all the column except the last column. Okay. Then we have df dot ilog last column. Okay. So here we have divided the data, and then from sklearn dot model selection, we are going to import train test split. Okay. We are going to import train test split. So X train, X test, Y train, and Y test. So train test split X comma Y, test size 30%, and random state is equals to 1. Right. So this is the train test split that we have done. Now, as already informed, that we are going to create multiple models, guys. Okay, we are going to create KNN model, we are going to create logistic regression model, SVM model, and a decision tree model. Okay, but the problem is I'm not going to keep on writing those four lines of code again and again, evaluating the model, checking the bias and variance terms again and again for each and every model. Okay, so this is where we are going to use the knowledge of Python programming here. Okay, what I'm going to do is I'm planning to create a function which will do all these repetitive tasks for me. Okay, instead of creating a model four times, okay, and checking the bias and variance for those four models and evaluating those four models, I'll write it once and I'll pass my method, or you can say I'll reuse that again and again instead of repeating those steps. So I'm planning to make a function. The function name would be my model. Okay, the function name would be my model, which will take a model as a parameter. All right, we will train the model. So first step, model creation. Okay, first step is model creation. So model dot fit x train y train. Then we have y pred is equals to model dot predict x test. Okay, so here we have finished with the model creation and checking the value for y x test. Right, now I'll be checking the bias and variance. So checking bias and variance of the model. Right, so model dot score x train y train. This will give me the training accuracy, and I will save it in a variable called train. Similarly, we will do the same thing for testing data. So model dot score x test y test, and I will print these accuracies here. So training accuracy, train, and let's say in the new line, testing accuracy. In the new line, testing accuracy test. Also, model evaluation, right? Model evaluation. So print classification report, y test and y pred, right? Print classification report, y test and y pred. And what I'm going to do is I'll just return the model back. So whatever model I have created, whatever model I have trained here, I will return that model back. Okay. So this is what my function does, right? This is what my function does. So let us create the, or you can say, let us import our different models. So at first from sklearn.neighbors, okay, from sklearn.neighbors, import k neighbors classifier, right? Then from sklearn dot linear model, we will import logistic regression. From sklearn.svm, I will import svc. Then lastly, from sklearn.tree, we will import decision tree classifier. All right, decision tree classifier. That is what we are going to import. Also, guys, if you notice here, we have used classification report. So we need to import that as well. So from sklearn dot matrix, I will import classification report as well. Now what my plan is, I will call the model. Okay, I will call the model. So k neighbors classifier. This is the name of the model. Okay, right. And what this function takes your model, and what it returns your model only, the trained model basically. All right. So what I'm planning is I will pass this k neighbors classifier into my model function. Okay. So what will happen is this k neighbors classifier, all right. Okay, for this k neighbors classifier, there will be an object created called as model. We will train that model. Okay, we will evaluate those models on bias, variance, and classification report, and we will return that trained model back. Alright, and I will save this model which we are returning, the trained model, in the variable called knn. Okay, so this is what we are doing. Alright, so if I run this, this will give me the training accuracy and testing accuracy after training the model, as well as the classification report for the model. So if I run this, as you can see here, we have the training accuracy as 95 and testing accuracy as 97. Okay, so we have high bias and low variance. Okay, high bias and low variance, which is underfitting. Okay, then we have this classification report which gives me 98% accuracy, but again this is a underfitted model. Okay, let me do one more thing. Let's just go in the two new lines, okay, so that we can have some space for classification report. I will do the exact same thing for all the other models. So my model function, I will feed logistic regression model here. So logistic regression, and whatever this function will return, I will save it in a logreg variable. So if I run this will return the training accuracy and testing accuracy for logistic regression model. Now if you observe this closely, guys, okay, if you observe this closely, training accuracy is 98 and testing accuracy is 97.7, which is again 98%. So here on iris data with logistic regression model, we are getting best fit model with low bias and low variance, right? We are getting best fit model for low bias and low variance. right? Let's continue. Let's create the third model, which is of SVC. So my model SVC will call the model, and we will save the trained model in a variable called SVM. So this is what it returns: 96 and 97. Okay, almost best fit, you can say. Okay, almost best fit, you can say. But again, if you compare it, so there is high bias and low variance, again the underfitting situation. Okay, SVC was also giving me some underfitting situation. So now let us try with your decision tree model. So my model, decision tree classifier. Okay. And whatever it returns, I'll save it in DT variable. So if I run this, as you can see here, as per the theory that we have learned, decision tree, as it automatically selects the good features, feature selection happens here automatically, it is overfitting the data on our data. It is giving me overfitted result, okay, with the low bias and high variance. All right. So what to do next? So guys, once you have created your baseline model, okay, now we all know when it comes to SVM, as it works on dimensions. So let us try to feed the scaled data. Okay, let us scale the data and try to feed in SVM on all the different models. Let us check whether it can improve, or you can say scaling can improve the accuracy. All right, let us check that. Okay, so from sklearn dot pre-processing, import standard scaler, SC object, standard scaler, SC dot fit, transform, xtrain. I will save it in xtrain variable itself. Okay. So once the calculation is done, we just have to transform it. Xtest is equals to SC dot transform xtest. Right. So here we have uh, completed with the scaling the data. So let us try to create the same models with the scaled data, okay, and check whether it can improve our accuracy or not. So KNN is equals to my model K neighbors classifier, right? K neighbors classifier. So again, this gives me, I guess, the same result. Yes, it gives me same result for KNN. Let's check it for logistic regression. So log reg my model logistic regression. So for logistic regression, now previously we were getting the good fit model, but now uh, we are getting kind of a low bias and high variance scenario, which is an overfitting scenario. Let's check SVM. So SVM, my model SVC. Okay. So this is again low bias and high variance scenario. Okay, it has not been improved. And what about decision tree? So dt is equals to my model decision tree classifier. So mm, no, there is no good result that has been found here. Okay, so we are not at all able to optimize our models with the scaled data, right? We're not able to optimize our model on the scaled data. So what next? Next comes hyperparameter tuning. So guys, we have already understood that how to tune your KNN model, SVM model, right? So let us today understand that how to tune your decision tree model. If you remember yesterday's session, okay, there is certain parameters like criterion that on which uh, measure of impurity, we have to execute our algorithm. There are two measure of impurities, that is Gini index and entropy, right? Also, I have informed you, if you want to control the length of the tree, you need to tune your max depth parameter, and if you want to control the width of your tree, you need to tune the min samples leaf parameter, right? So there are certain, let's say, parameters here in decision tree. If I show you, so there is criterion, which is by default set as Gini. Okay, there is a criterion which is by default set as Gini over here. Max depth is none by default, and min samples leap is 1. Okay, there are many multiple parameters, but these are the most common and useful parameters for us. Okay, so since we are going to have multiple values for this parameter, I'm again going to use grid search CV, guys. All right, so let us create the parameters for hyperparameter tuning. So what would be the parameters? Okay, at first I will tune on criterion parameter. Criterion, right? Criterion parameter, and the value of criterion is nothing but, there are two values, default Gini and entropy. Okay, Gini and entropy are the two values, right? Then we have max depth. Okay, max depth. Now what I want to do is, I want to try for many different depth, with one depth, two depth, 3, 4, 5, 6 till 20, let's say. Okay, so what I'm going to pass is, I'm going to pass a list of range 1 to 20, right? Similarly, in min sample leaf, okay, in min samples leaf, I'll do the same thing. So list range 1 to 20. Okay, so these are my parameters. Now if you don't understand that what exactly this list range does, so let me show you. So if you do this list range 1 to 20, this will give you a list populated with numbers 1 to 19. Okay, so what will happen is, first one model will be created with depth 1, then in second iteration, next model will be created with depth 2, depth 3, depth 4, and so on. Okay, so there are such 20 models will be created with max depth. Similarly, same thing goes for min sample leaf. Okay, so there will be many iterations, guys. There will be many, let's say, models which will be creating inside. Okay, so these are my parameters. Let us call our grid search class. So from sklearn.model selection, import grid search CV. Okay, grid search CV. I'll create an object called grid. All right, and here grid search CV. Okay, we will call the decision tree class. Okay, decision tree classifier. Here I will feed the parameters, right? I will feed the parameters with verbose 2, right? With verbose 2, and I'll use grid dot fit x train and y train. Okay, so if I run this, guys, parameters not defined. I guess there's spelling mistake here. So parameters. As you can see here, there is 722 candidates, more than 3610 fits. Okay, 720 candidates with more than 3610 fits. Okay, so this many models are getting created. Okay, so if I just check with grid and best score, so grid dot best score, so 95 is the best score that we are getting with the low bias, low variance scenario. Okay, what are the best estimator. So grid dot best underscore estimator. So max depth 3 is the best estimator, guys. Okay. So if you create your decision tree model with max depth 3, that would give you a best accuracy, or you can say the best fit model. Okay. So let us pass my model. Okay. In my model, let us pass this grid dot best estimator. Right. Grid dot best estimator, and whatever it returns, I'll save it back in DT. Whatever it returns, I'll save it back in DT. So if I run this, now as you can see, we have managed to create a best fitted decision tree model with low bias and low variance. Training accuracy is again 98%. Testing accuracy is 97.7. That is again 98. So here we are getting a low bias, low variance scenario, guys. Okay, so we have managed to tune your decision tree model for best fit. Okay, not only this, okay, not only this, if you remember yesterday we had seen a diagrammatic representation of your decision tree algorithm. We can do that here in coding as well. Okay, so what I'm going to do is I'll just use this sklearn. Okay, from sklearn import tree. Okay, I'll be using some figure and plot. So fig with axes, plt dot subplots, actually subplots with figure size, with figure size 20 and 15. Okay, so width 20 and height 15, or you can say row and column. That is what we are giving over here, right? So tree dot plot underscore tree, this is the method that we are going to call. I will pass my model of dt, which we have uh, saved here. This is the variable of dt, the recent dt variable. Okay, and then I will give the feature underscore names parameter. What are feature names? Feature name is nothing but iris dot feature names attribute, right? That has the column names that we want. Okay, so now if I just use plt dot show, that will end up giving me your tree. Okay, like this. Now this is not looking good, right? This tree is not looking that good. What I'm going to do is I'll just use one more parameter called filled. Okay, I'll be using one more parameter called filled equals true. If I do that, filled equals true, this will give me a colorful uh, representation, right? A colorful representation here. So with white, actually not white, it's like slightly gray, right? So gray, then orange, and some different colors here. Okay, so this is how we implement a decision tree. Okay, this is how we can implement decision tree. Same 4 steps: import the model. Okay, create the object for your class, train the model, and make prediction. Okay, same steps. Okay, but for hyperparameter tuning, we mostly tune these 3 parameters, that is criterion, max depth, and min samples leaf. Okay, criterion, max depth, and min sample leaves. Okay, so this is what, and this is actually how we make a case study with all the eda pre-processing is done. Okay, this is an ideal case study, guys, from my point of view. Is that clear till here? सबको यहाँ पे हम लोग ने जो भी किया है, is that clear?